Dates and times in SQL Server can be confusing due to the way that the server stores and presents dates in results. In this video, I hope to clear up some of the ambiguity and give you an understanding of how dates work in SQL and the various ways you can manipulate dates to get the date you want, and how to present the date in a format that you can use in your reports and applications. There are a few basic date and time data types you will come across when trying to query SQL Server. Let's go over these one by one to outline some of the key features. The most common type is the date-time data type. This has been around for a long time, so will be used in countless databases created before the new types were introduced, and continues to be used as it's familiar to the majority of the SQL coders out there. The date-time data type can store a whole date since 1753, but its default value is set at the 1st of January 1900. More about what I mean by the default value shortly. The maximum date you can store in this data type is up to the 31st of December 1999. As its name would suggest, datetime also stores the time values and can go down to increments of 0.003 seconds, although cannot increment the time values by anything less than this, so in-between values will not register until the next step is reached. If you need to store time values in smaller increments, you can use one of the newer data types mentioned shortly. The next data type is the small datetime. Whereas datetime takes up 8 bytes of data every time you use it in a row in your table, the small datetime data type takes up 4 bytes. This means it will take up half the space, but consequently can store a smaller range of datetime values. The earliest date that a small datetime can store is the 1st of January 1900, and can go up to the 6th of June 2079, and the maximum time fractions available is 1 second. Next we move on to the newer date and time data types introduced in SQL Server 2008. These address a couple of different shortcomings of the datetime data type from earlier versions. First we have DATETIME2. This was designed to replace datetime in your new tables. DATETIME2 has a user-defined fractional precision, which means you can change how many bytes DATETIME2 takes up, based on your precision requirements. At the default precision, DATETIME2 can have a range from the year 1 on January the 1st, all the way up to December the 31st, 1999, and a time up to the precision of 100 nanoseconds. You can specify the precision, similar to how you would with other data types, by including it in the brackets when you define the variable or column. With no precision specified, the data type defaults to a precision of 7, which means it can accept a maximum of 7 digits of precision in fractional seconds. Specifying less precision removes a digit with each decrease until the precision is 0, giving no fractions of a second. For the longest time, you had to store dates with time values as your only option. To store only the date, the time had to be set at midnight, and if you wanted to store the time only, the date had to be set to the default date of 1900-0101. But now you have the date data type and the time data type, so these two types can be used to store date and time values independently. The date data type is only 3 bytes long, so saves on space when in use. You can store dates between the year 1, January the 1st, and 9999, December the 31st. The time data type has a precision option, just like the DATETIME2 data type, meaning you can store the times with a maximum precision of 100 nanoseconds, and can reduce the space used by reducing the precision to the level you need on a case-by-case situation. As a summary, here are all the date and time data types mentioned, along with the date-time offset type, which has the same precision settings as the DATETIME2, but allows you to include a value to store the time zone offset for time values outside your own local time zone. This table is available on the Microsoft documentation website shown here, along with more technical detail on each data type. Any links mentioned in the video will also be in the video description. You may have noticed that datetime formats in different countries are laid out in a different order. Some start with the day, then month and year. Others start with the year, month, or day. There's also differences between the types of separator used to define the different parts of a date. To allow a more uniform representation of dates, and to fit dates into a computer-readable format, dates within data structures are stored as numbers. I mentioned earlier that the datetime data type took up 8 bytes of data. 4 of these bytes represent the date, and the other 4 represent the time. In the case of the datetime data type, with the first 4 bytes, every additional increment of 1 represents an additional day, and for the second 4 bytes, each 1 fraction represents 0.003 of a second since midnight. I also suggested that dates had a default value. What I meant by that was if a date's numerical representation is set to 0, then the value that 0 represents in the selected format will be the default value. In the case of a datetime data type, this is the 1st of January 1900, and each time we increase this value by 1, we add 1 day to the date. So if we wanted to store the date of the 20th of January 1900, then the number we store as a date would actually be 19. With a time value, the 4 bytes represent a fraction of a day, so 0 would represent no fractions past midnight, and it would take 12,960,000 fractions of 0.003 to record the time value of 12 o'clock midday in the datetime field. Given this information, you can see that SQL Server's date storage can be independent of any kind of local formatting for dates. When you try to use dates in your queries, either in a where clause to find rows with or between some dates, or enter dates into a table, it's important to remember that SQL Server is trying to interpret those dates in a format that may not be the one you're used to, in order to convert it into the neutral numerical representation of a date value. If we select the datetime field from a table, the results brought back include metadata to let the application know that the data is a datetime value, and the application can format it as required. This is the best approach, as the date keeps all its properties when being consumed by the application. Moving over to Management Studio for a second, you can see that bringing back a datetime in Management Studio formats this as year, month, day, separated by dashes, and hour, minute, second, separated by colons. If we'd like to convert it into a string in our own format in the SQL code, we can do that by using the convert function and specifying a style code. The website here shows all the available style codes for the convert function. I've added this to the video description for reference. Depending on these style values, SQL Server will return a varchar result formatted in the appropriate style. Let's try to show the datetime field here in the simple US date format of month, day, year, and include the time as AM or PM. To do this, add in the style number 22 in the conversion function. Note that because we have converted the field into a varchar data type, any downstream applications or reports will receive it as a string type and won't automatically try to convert it to a date. This may cause issues if you try and order the information, as it would be ordering alphabetically rather than by date. To remove the date or time sections, use a style code that results in only those sections. For example, you can use 103 to return the date in the UK and French format, or 108 to return the time as hours, minutes, and seconds. In newer versions of SQL Server, we also have the format function, which is a .NET extension which allows the freedom to specify exactly where to place the date parts, and allows for your own separators or additional formatting of dates or numbers. To output the date in a UK format, as we did before, we can add the formatting codes that represent the day, month, and year into the format string, as here. Notice I've used a convert function to convert the string date value into a datetime data type before trying to format it. More on converting strings to dates in the next section. If we run this, it returns the date as a string data type in the format we specified. There are lots of useful formatting codes in this function. You can see these on the Microsoft website article mentioned here. There are options to display the date, time, AM and PM, and others in this list, as well as other formatting codes to present numbers with commas or a set number of decimal places. It's also possible to give your format additional text to really set out the style you want. But bear in mind that if you use text that could be interpreted as formatting codes, you need to prefix them with an escape character, so the server knows what you want to output as a value and what you want to output as text. Here I have a format code that I want to output as day, then day value of month name, value, in the year, then the year value. But if we run this, the server returns a bit of a jumble, where the characters I've used are part of the codes used for the format function. To fix this, I can place the escape character / before any characters that are special codes. This will tell the server that I want these as text and not as formatting codes. Run this again and it gives us the result we want. If we want to filter results in a where clause, or update a table with a data type value, it's important to know the format to use. As we saw earlier, when presenting the date value to a user, it all depends on the regional setup on the server. So different configurations may expect different formats as the date value. This is the table we'll be using for the demonstration in the video. If we want to select only the rows where the date value is equal to the 1st of October 2021, we might filter like this. The date here is in the UK format of day, month and year. Running this brings back the rows where the date is actually the 10th of January 2021. You can guess that SQL Server has interpreted the date string we entered incorrectly and is expecting the US format of month, day, year. This can be confusing, especially if you don't notice the first time. You could easily bring back the wrong results in the query and assume that it ran correctly. The only foolproof format for a date string is the ISO style of year, month, and day with no separators. This will be reliably interpreted correctly in any locale. If we use this in our select query, it does indeed bring back the dates we're expecting. We can also add the time values in this format. When using dates in a string format, I prefer the ISO 8601 format that includes separators for the date values, like this. Notice the T character between the date and the time values. This is part of the ISO 8601 standard. You may be able to omit this character and replace it with a space instead. This changes it to the ODBC date format, which is slightly less reliable in certain circumstances, so you should experiment with which format works best for you on your server setups. I mentioned before that you can use the convert function on a date to retrieve only the date value by specifying a style that excludes the date. If we use style 103 to convert this datetime data type into a string, it removes the time value and returns only the date in the UK format. But now this is a varchar data type and is no longer usable as a date. Sorting on this field will return rows that will be ordered alphabetically, rather than by date value. In order to remove the time from the date and still have a datetime field, we need to convert back to a datetime field after we've removed the time. We can do this in the same way by using convert datetime. Note what we've mentioned before about converting from a string to a date, in that the server will need the string to be in a format it can interpret back to a date. You can use the style code to tell SQL Server what format to expect your string date format to be. In our case, we can use the same code we used to remove the time value when we converted to a varchar. With the new data types came an alternative solution to this problem. Now, instead of converting to and from a string value, we can convert datetime straight to one of the new date or time data types. Converting to these types allows you to keep the data type as a date for further processing and reduces the number of steps the server must take. Also, because the original data type is already a datetime, there's no need to supply a style code. Next, you've probably come across scenarios where it will be useful to retrieve the current date and time. We can easily do this with one of the two functions for this purpose. Originally, this was handled by the getDate function, and it's likely you'll see this in lots of existing code. The new function is current timestamp and is an ISO standard for SQL coding. This means that this function should be usable on any version of SQL that conforms with the standard, giving your knowledge much more scope and allowing code to be written in one system to be used on a different database platform. You should use the current timestamp on any new code you write, providing your version of SQL Server is 2008 or above. If you run both functions, you can see that the resultant dates are identical. In code, these two functions are interchangeable and will produce the same results. It's often useful in SQL to retrieve parts of a date, such as the year or the hour. This can help with grouping into reports, for example. To do this, there are two functions: the DATEPART function used to retrieve the parts as a numeric value, and the DATETIME function used to get the name of a month or a weekday as a string value. DATEPART accepts two parameters. The first is the name of the date part you want to grab from the date. The second is the date field or variable. There are quite a few DATEPART names ranging from year right down to nanosecond and everything in between. There are also shortcuts for each DATEPART, but it's not recommended to use these as they can be ambiguous. If we use a few of these DATEPARTs in a query on our orders table, you can see that the order datetime field can be split into its various components. You can see all the DATEPART names on the Microsoft website in the description. And with the DATENAME function, you can use month or weekday to get the text representation of those DATEPARTs. It's often useful to find the difference between two dates. With this, you can do things like find the number of days between when an item was ordered and when it was delivered, or maybe the number of months since a particular customer has visited your website. The DATEDIFF function combines the utility of the DATEPART function and allows you to get the number of periods between two dates. Using our orders example table, we can calculate the number of days between the order and the delivery date using the day value as the date part, then the earliest date and the latest date. Run this to see the number of days between the order and the delivery. Using month as the date part value, we can see the number of months between the order and the last visit values. DATEDIFF can also be used with any other date part period value to find the number of hours, years, minutes, etc. between two datetime values. And lastly, the DATEADD function lets you add date part periods to a date. This way you can reliably add a number of months, for example. Here we want to add 2 months to each of our order dates. The function also lets you subtract periods from dates by using negative figures. This query subtracts 1 year from each order date. Okay, let's put some of this together and actually do something useful. Often we need to bring back results where the dates in our table are between 2 date values, and often these are set periods, such as last month or last quarter. There are many clever ways to do this based on how SQL Server stores dates. Firstly, let's try to get the dates between the first and the last date of the last month. There's a useful function we can use to help us here, which is the EOMonth function, which gives us the last day in a month. This function is available in the SQL Server version 2012 onward. Just enter the date of the month you want to find the end of into the EOMonth function to get the end date. Remember to format the string in a way that the server will interpret correctly if you aren't using a datetime field or variable. Next we need the beginning of the month. This time we can minus 1 month from our current month, then add 1 day. The EOMonth function has an additional parameter that lets you add or subtract months from the value. So if we use -1, this takes us to the end of the month before. Next we just need to add 1 day to the value to get the first of the current month, for which we can use the DATEADD function. Now we can put these two together to search for orders made between the first and the last of the selected month. If you're using a version before 2012, then you can use DATEADD and DATEDIFF to perform a similar function. This method will also help us with different time periods, as I'll show shortly. To get the beginning of the month, use this function. This works by firstly getting the number of months between the date and the default date. That is where the numeric value of the datetime field is 0, which, as we saw earlier, is the 1st of January 1900 in the case of a datetime data type. This gives you a total of 1,461 months since January 1st, 1900. Then the next step is to add the number of months to the default date. So in our case, that's to add 1,461 months to the end of the 1st of January 1900, which gives us the first date in the month we wanted, which is of course the 1st of October 2021. The great thing about this calculation is that we can use it to get the first date of any period we can define as our date part. So the first date in the week of the date we're examining would be this. Or you could even use the quarter date part value to get the first date in the quarter for our date. To get the last date in the period, we can use a similar method to how we derive the first day of the period using the EOMonth function. This time by getting the date of the beginning of the next highest period, then subtracting 1 day. In our case, we need 1 more date part period for the month. We can do this by subtracting the number of months from our 0 date, just here. Since we want the number of months we bring back from our DATEDIFF function to include 1 more month for our next month end date. So however many periods we want to include, use the negative of this. In our case, we want 1 whole month, so -1 is the value we use here. Then we can subtract 1 day from this date to get the last date in the previous period. Now we can put all this together to find out the orders received in the selected month by adding these 2 start and end date periods in the where clause as a between operator. Here we're selecting all the rows from our orders table, where the order date is between the 1st of October 2021 and the 31st of October 2021, using the functions we've just discussed. Run this to see all the orders taken in the month of October. You can use this technique to get the date ranges dynamically using the current timestamp function to get the current date and time. Here you can see that we've used the current timestamp function to bring back all the rows where the order date is the current month. Thank you for watching my introduction to the SQL Server date and time data types. You should now have a better understanding of how SQL Server sees and uses dates in the database, and be able to use dates inside your SQL code to perform filtering and converting into the formats you need. Please let me know your thoughts in the comments below, and if you have any questions or suggestions on future videos. And like and subscribe for more content.